Hello all and welcome. Today we're going to discuss next generation testing. My name is Corey Tinkus and I'm with the business development team here at Ixia Solutions Group at Keysight Technologies. I'm joined by Daniel Mountain-Yu from Ixia Product Management and Young Zhao from Ixia Sales. And we're excited to talk about a new approach to networked application and network security testing. Let's get started by reviewing typical challenges with today's network testing techniques. Welcome, Daniel. Can you tell us why customers need a new and evolved approach to network testing? What's changed in terms of their pain points?
Sure. Thank you, Kari, and welcome everyone. I would first start by saying that the most effective approach to test and validate network infrastructure elements, like, for example, next generation firewalls, the packet inspection solution, and so on, would be to precisely simulate production network traffic to observe how the traffic performs and fix any identified issues. Obviously, all this is preferable to do before the devices are actually placed into the service for the real users, right? Now, let's discuss what have been the typical approach, historically speaking, to generate this kind of production-like traffic in the lab. And the first and the most common, I would say, at least again from the historical perspective, was to use a packet replay, right? So to just take a packet capture from the production network and to replay it in the lab. While this approach is useful, as it is very close to the production environments, there are a number of issues associated with it. And I will start by saying that it's quite time-consuming, it lacks flexibility, and has a very limited coverage since, as we all know, the packet captures can grow quite high in size. They can be quite large, right? And most importantly, they do introduce privacy issues. Since you have the entire packet payload, you actually have access to the end user data, and obviously this creates privacy issues, right? So that's with the packet replay approach. The second technique is to just use a test tool and manually construct a network traffic profile according to what is expected on the production network, right? And this is, I would say, the modern approach. While this is also a good approach, it can definitely be improved. And for example, the areas where further improvements can be brought are, first of all, with regards to the configuration overhead, and sometimes it's a bit time consuming to manually profile the production traffic and set up the emulated traffic model exactly as that production traffic. And the second thing is that we can definitely also improve the temporal behavior, right? Currently with this approach, the temporal behavior, it's not ideal, because many times the same application mix that you build with a test tool would be ran from the beginning to the end of the test, and that's not really ideal.
So if the classical challenge has been to adequately test network devices and applications before they're launched to real users, listening to you, Daniel, it sounds like what's changed or what's required more than ever is how to quickly and easily and accurately create tests and test scenarios that simulate production traffic much more faithfully and accurately than historically. And in particular, to preserve this time-based or temporal nature of the packets transmitted. And in doing all of that, eliminating data privacy concerns. Can you tell us more about what's needed to address this challenge?
Right. So here at Keysight's Ixia Engineering, we believe that we need to transition from this, right? And I'm sure that all the Super Mario Bros. Fans out there would recognize this icon as the first version of the character, to something more like this, which is its evolved three-dimensional version, right? So in reality, we just aim to add this extra dimension to ensure an effective level of realism. Getting back to this end goal, I would say that the ideal solution would need to provide a high level of application traffic intelligence so that the emulated applications would be relevant for the production environment. Then the same solution would need to be performant so it can scale to high traffic volumes. And last but not the least, this solution would also need to provide a streamlined process for a simple setup and configuration. Now, with all these things in mind, we have introduced TrafficREWIND. TrafficREWIND is a unique patent-pending solution which helps translating production traffic insights into realistic traffic configuration for test lab environments.
Well, I think many of us can relate to your analogy, Daniel. And you've introduced the Ixia product, TrafficREWIND, which sounds like it provides an effective strategy and approach to meet these needs. Can you give us more details about this solution?
Absolutely. So let's briefly review how TrafficREWIND solution components work and how they come together, right? And first, obviously, we need to start with the production traffic, right? And as we can see here on the left-hand side, we have the production network traffic, which is being inspected by Ixia's app stack, which is powered by ATIP. And these Ixia's app stack is inspecting the real production traffic. And based on that, it generates traffic metadata in the form of net flow. This net flow information is sent over to TrafficREWIND, right, which is in the middle here, which records and synthesizes traffic characteristics. And based on this, it can generate a test configuration file. The key point here is that we are working with net flow, right, which is traffic metadata. So basically, we are not sending the entire traffic payload. Therefore, the privacy issues related to sending the actual traffic payload are eliminated. Now, once we have this traffic summarized by the the net flow summarized by the TrafficREWIND virtual appliance, we can then take a test configuration file and upload it into Ixia's breaking point test solution. Another point that I would like to summarize, since we are also touching on the breaking point test solution, is that aside from running these TrafficREWIND exported configs, Ixia's breaking point test solution has also a wider array of functionalities, like, for example, simulating real-world legitimate traffic, distributed denial of service, exploits, malware, and even fuzzing to help validate an organization's network and security infrastructure, reducing the risk of network degradation and increasing the attack readiness. However, again, as part of this session, we will only discuss TrafficREWIND. Therefore, for more details on the breaking point test tool solution, please visit our website at ixiacom.com.
So you've outlined a solution here, Daniel, that has three components: AppStack, TrafficREWIND, and Breaking Point. And as you've described it, it addresses the needs of the customers in this new world of requiring very faithful traffic recreation and preservation of the temporal nature of the traffic. It sounds quite innovative and perhaps even disruptive to some of the classical approaches taken towards test methodologies. This seems like a perfect time for a demonstration. Yang, can you show us the solution in action?
Thank you, Corey. Hello, everyone. My name is Yang Zhao. I'd like to give you a live demo of our Ixia's TrafficREWIND solution. As Corey and Daniel mentioned early on, the TrafficREWIND solution including three major pieces of our product. The first one, let's dive into the application thread intelligent processor, or we call the app stack. Let me log in to the app stack. When we get into the app stack, and from this screen, you can see that the live traffic has been feeding to our ATIP or app stack. And then you can see from the dashboard that we have about close to 19 gigabit per second traffic, live traffic being fed in. And also from our app stack, we basically sensitize and analyze what is the traffic look like. And in this screen, you can see there's a YouTube, there's HTTP, regular HTTP traffic, there's Apple applications, there's HLS, video traffic, there's Google Quick, and a bunch more. Beyond that, on the third screen here, small screen here, we can also see the latest dynamic applications the customer traffic look like. Sending it over. So all those intelligence, will we detect the layer 7 traffic, as Daniel mentioned early on, will translate it into the metadata in the transform of NetFlow traffic record. And in this case, I'm showing you our NetFlow settings on the app stack. And you can see that on this box, we have NetFlow enabled, and we set the proper NetFlow versions. In this case, it's version 10 IPFix. The reason why we're using IPFix because it has a rich vendor-specific attributes. As you can see on the right-hand side, we're using a lot of Ixia-specific IXFlow field. And as you're looking through all those options we enabled, and you can see the depths and the broadness of what we can detect the layer 7 application traffic, and also precisely, accurately describe and present those application traffic to our next hop, which is the TrafficREWIND. And here, I'd like to show you our NetFlow statistics. Remember that early screen, we showed that we have a over 19 gigabit per second, a blended customer live applications coming in. And those things, as you can see in this field, translating into NetFlow record. In this case, we have about 87 megabit per second NetFlow traffic, record flow traffic sent into the TrafficREWIND appliances. So as the natural next step, let's log into our TrafficREWIND appliances. As Daniel mentioned early on, the TrafficREWIND appliances is our virtual appliances, which just collect the NetFlow traffic sent from our app stack and sensitize it into the metadata file, which is later on can play it out on our breaking point testing platforms. So this is when we log in, and you can see a quick view of the display page or dashboard of TrafficREWIND appliances. As you can see, I have some traffic running over the last few days. What I want to do is kind of zoom in to what we have seen lately, what's happening for the last 30 or 1 hour time frame. And you can see in this screen, the top part of it is what we call the top applications, top 9 plus all the others, so total of 10 items, and distributed and displayed by the traffic volume and by the number of sessions count. And you can see we have seen accurately reflect what we've seen from the app stacks. There's YouTube, there's HLS, Netflix, Apple, Google Quick, and all those traffic. The middle part of the screen you will see is really the traffic volume. The brown part is the downstream traffic, and the yellowish part of it is upstream traffic. Apparently, for the live traffic, most of the time they're asymmetric, and then you can see the distribution of that. And then this is over the time, what I set it up from 11:15 till 12 o'clock as we speak. Those are the live traffic coming in. Those are being described and displayed on the traffic rewind. Setting up a traffic rewind is fairly simple. What you really need to have is, in this case, our application traffic rewind is running as a standalone mode. What that means is that one application traffic rewind appliances is running both as collecting and analyzing data, but also displaying it. On the Traffic Rewind 2.0, which is the current version we're running, we're also supporting multiple other modes. For example, we can supporting as a processor mode, or we can support as a controller mode, which just give you a more combination of processor mode and controller mode, give you a more distributed architecture, which is allow you to go beyond 220 gig or up to 20 gig of live traffic. We can go higher and higher, go to 100 gig or even beyond, with multiple processors and a single controller, give you a single pane of central control. So for this particular live demos, as I mentioned earlier, this is a very basic sample standalone processor. And as you can see, we are receiving net flow from this particular IP address, which is the app stack. Now, if I'm switching back to this, what I'm going to do is I'm going to capture about 25 minutes of the live traffic. As you can see at the bottom, if I change the time widget, and I can see start time at 11:45 and the end time is 12:10. Okay, let me export this metadata out from the Traffic Rewind appliances. Now you can see the metadata has been downloaded. Now moving to the third leg of our Traffic Rewind solution, which is Breaking Point Test Platform. Let's first open the test console. As some of you know, that Breaking Point is a very powerful platform, which is you can emulate the application mix of the real network traffic. But you do need to carefully craft the traffic profile beforehand. In this Traffic Rewind solutions, Traffic Rewind appliances provide this metadata, which is we just downloaded. So right now, let's import that, which is a 25 minutes metadata of live application profiles. So first, I'm uploading that onto the Breaking Point Test Platform. As you can see, under this window is shown a list of emulated traffic, well-known applications, as well as a lot of dynamic application transactions. Next, what I'm going to do is create a new test. Instead of adding a traditional application simulator or session senders or client simulator or security attacks, in this case, I'm going to choose the live AppSim test components, which is going to refer to the live application profiles, which we just imported. As you know, for this live profile application run, there's no need for you to set any speed or duration or anything like that. You can simply play it out. Breaking Point Test Platform, based on the metadata we got from the Traffic Rewind appliances, will faithfully play out the application mix and according to their volume in a faithful way. which is what I'm going to show you in the short seconds. I'm going to save this test at sample tr. While we were waiting for the test to be initialized and the live traffic to be emulated, I'm going to give you a preview of what I'm going to do next. First, we're going to look at the overall, whether the traffic is playing out properly on the test platform. Second, we're going to look at whether it's play out faithfully, whether it's play out according to what the live traffic, which is being profiled and captured by the TrafficREWIND appliances. Now you can see the traffic is running, and we have a very high rate of TCPs and UDPs. You can see the concurrent flows. You can see the application transaction rate. But the most important thing you can see is a bandwidth, which is close to 19 gigabit per second, which is exactly what we captured early on in the TrafficREWIND appliances. Now, the next thing I would like to go is take a look at the application tab. And now here, you can see those well-known applications which is being played out. Live AppSim tab is a new tab which is we created for this TrafficREWIND playout capabilities. In this tab, and you can see all the dynamic superflows or application we've been played out, as well as those well-known superflows or applications we emulated. Let's take a look at this Facebook superflow. When I select this one, on the right-hand side, we will provide you a comparison chart. As you can see, the original and desired megabit per second, which is in this case about 400 megabit per second of Facebook traffic, is compared with the achieved, which is currently being emulated, of the Facebook transactions, which is very, very close in this case. What we can conclude here is that Facebook application has been faithfully emulated with this live AppSim playout. If I choose another one, which is HTTP live streaming, and you can see similar thing happen on the right-hand side, which is very closely played out. In summary, you can see that it's how easy the TrafficREWIND application, TrafficREWIND solutions is enable the testing with the feed of the live application feed. The whole process is more automated. There's no more guessing game. There's no more hours of crunching the traffic models. So this concludes the short live demo for you. Now back to Corey.
Thanks, Yang. So just to summarize what we've seen, you've used AppStack to generate NetFlow records. You've used TrafficREWIND to further genericize those records and eliminate any privacy concerns, and to export test configurations that have been imported into Breaking Point to faithfully rerun that production traffic. Is that an accurate summary of what we've seen?
Yes, absolutely.
Well, very good. You sure made it look easy with a few clicks in each application. So from here, let's go forward and talk about how customers are using this TrafficREWIND solution in their testing today. Can you tell us more, please?
Sure, Corey. We normally see three major use cases. The most common use cases here is to perform pre-deployment validations with production-like application mix. We used to be the users always struggle and spend a lot of time trying to tweak and trying to come up with production-like traffic. They spend a lot of time, they're trying to match it, but they never have a very good sounding result of that. Think about large enterprise, for example, which need to validate the reliability of the production network when adding or replacing the network devices. For example, next generation firewalls or IPS or IDS. Or when they trying to upgrade to a new software version of existing infrastructure elements. It always takes a lot of time, but every work is sort of more guessmate. In these cases, testing with relevant production-like application traffic powered by XCS TrafficREWIND solution is critical to get increased confidence for upcoming live production changes. Moving on to the next use cases, which is an interesting one to prepare for the unknowns. A lot of times, network engineers or service providers, they are really anxious about what's going to happen next. What if situations. Here we're talking about expected legitimate traffic growth, like when promoting new offers for unlimited internet traffic, or when validating secure attacks along legitimate traffic. In these cases, the starting point should be the baseline traffic, which again should be as close as possible to production, and then layer in additional application traffic to see how the infrastructure behave, or even assess network security solutions by adding additional security strikes or DDoS attacks. The third use case is for solution and customer proof of concept. When network element manufacturer or system integrators is putting together a network security solution for a potential customer, there will be no more guessing game of the real customer traffic profiles with the assistance of XCS TrafficREWIND solution. In these cases, both parties will have the peace of mind of the proposed network security solutions with the accurate temporal live traffic profile being played out.
Okay. So customers are using TrafficREWIND to save time, and as you describe it, it sounds like save a lot of time, to reduce their risks, and to improve certainty in their testing regime. Very good, thank you. Daniel, we're approaching the end of today's session. So having described the challenges and the solution and how customers are using the TrafficREWIND solution, can you summarize for our audience the key takeaways?
Sure, Corey. But first, I would like to take this opportunity and quickly summarize the main technical aspects of TrafficREWIND. And I would first start with the fact that TrafficREWIND can currently store network traffic characteristics for up to 7 days. Then out of those 7 days, users can easily select the segment of interest, which is up to 1 day, right? And that segment can be regenerated with a breaking point, as Yang just showed earlier. Another important and very unique characteristic is that each 15 minutes will have a different traffic distribution. What that means is that we are splitting the time segments into 15-minute intervals that have a different application distribution and a different traffic load. That's quite unique, and that helps preserving that temporal factor that I was mentioning at the beginning of this webinar. Also, as also emphasized many times across this webinar, we are using here traffic metadata, so not the actual traffic payload, right? In terms of the application support, we currently support up to 61 applications, and this database is continuously growing. And last but not the least, the TrafficREWIND itself is just a virtual appliance with no hardware dependencies, and it can be deployed on VMware ESXi environments or KVM. Now, getting back to your initial question, Corey, the most important takeaways that I would mention part of these sessions are as follows. First, with TrafficREWIND, we can enable an end-to-end solution that uses production network insights, which are captured from Ixia's app stack, to create configurations for Ixia's breaking point that ultimately generates realistic network traffic in a lab environment. This overall solution benefits network designers, validation, and operation departments in very specific and new ways, like creating more robust network and services, like for faster fault analysis and shorter MTTR or mean time to repair, and obviously better prepare for the future growth. Hope that this all makes sense, Corey.
Yeah, definitely, Daniel. Thanks very much for the summary. And thanks, Yang, for the demo. I think here today we've got some real insights into next generation testing and how customers are able to faithfully recreate production network traffic and address the complexity of testing in today's networked environment. And thanks for the detailed look into TrafficREWIND. For more information, please visit www.ixiacom.com to learn more. Thank you.